Cloud DB, shaping your new normal.
Good morning, good afternoon, good evening, depending where you are around the world. Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by APACO UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This will allow you to have access to all the replays until December 30 through the platform. I would like to say thanks to all Oracle user groups in Java user groups, all 16 of them that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, 10 mistakes that every DMA, DBA do in Oracle Exadata and how to avoid them in the future by Mani. Please feel free to ask questions at any time by using the chat window on your right lower corner of your screen, and Mani will be answering your questions at the end of the session. If you have any issues during the transmission, please feel free to use the same chat window on the right lower corner of your screen, and I will try to help you the best I can. Now, without any more further ado, I leave you with this amazing session by Mani. Mani, the room is yours.
Thank you, Alvarez. Thanks for all the great introduction. So am I hearing okay and my screen visible?
Yes, perfect.
Okay, great. So first of all, thanks everyone for joining the wonderful event, and many thanks to the APACO EG as well as all the sponsors for making this great event. So today we're going to talk about the 10 mistakes that every DBA or a DMA do in Oracle Exadata and how to avoid them for the future. So just to brief about me, I have about 15 years of experience in Oracle database and Exadata administration, and I'm also an Oracle ace. And here's my channel. So I'm running a YouTube channel called Tech DBA, and my LinkedIn profile as well as my technical blog. So just to brief about Exadata. So most of you are aware about Exadata, but I'll just try to give a quick background. So Exadata is not just an appliance, rather it's an intelligent and ideal database platform for Oracle database workloads. And the various components of Exadata, that includes the compute nodes, which is a database server, and the storage node, which acts as a storage devices. And we have an RDMA network that is nothing but IP key switches and the Ethernet switches. And we also have a power device units. And there are various configurations available for the Exadata that includes a 1/8 as well as quarter, half, full rack, and deployments. And the very important features that differentiates Exadata among the other conventional devices, that it's the secret sauce that is built within the storage layers. So the features that includes the smart scan or the cell offloading, hybrid columnar compression, storage indexes, the smart flash cache, the resource manager, as well as the new feature of Exitum, which is the persistent memory. So we're not going to talk about the features, rather we'll just quickly get into what we're going to discuss. So about the 10 mistakes, I just categorize into the various groups, so we can just follow it through the life cycle itself. So starting with the design, so we're going to talk about a couple of them, and then followed by an installation, and then what are all the mistakes we do during the configuration, health check, and the maintenance. So first thing on that design, we're going to talk about what are all the design considerations we need to do with respect to compute as well as storage server. So on the compute design, so the first decision that comes into a picture, whether it's a bare metal or a VM. So as you everyone aware, Exadata is heavy in terms of CPU processing as well as memory. So if you look at the key features which I pasted for Exitum, it has 912 CPU cores and up to 576 CPU cores per rack. and we have about 27 terabytes of persistent memory, as well as we have about 3 petabyte of raw disk capacity. So it's very huge in the capacity, but at the same time it is a cost expensive as well. So we have to make the use of the device so that it is we can able to get the maximum benefit out of the device. So the best features that enables that is the virtual machines. So there are some components that can be virtualized and some components that are shared, but still it is redundant. So first one is an Exadata compute node, which is a database server. So that can be converted into multiple database servers. So for example, you have a 2 compute instance at the physical that can be converted into multiple database server at the backend. Same way for the storage layers. So we have, for example, if it is a quarter rack, we have 3 storage servers or 4 storage servers that can be converted into multiple virtual ASM disks that can be mapped into multiple ASM devices at the database servers. Same way, the physical ports, we have 4 physical ports available for the compute as well as database server. So that can be virtualized into multiple ports that can be used for management network, client network, as well as the admin networks. So the some of the components that cannot be shared is an RDMA network. So there are some limitations over there. So it is not completely it is virtualized, but we can able to virtualize to some extent. Same way, it's a power device unit and the physical rack and hardware; those are not shared, but it still have a redundancy. When we look at the VM technology, we have 2 types of technologies. So up until Exatom, Exadata supports Zen-based hypervisor. So with the new Exatom, it's introduced with the kernel VMs, which has more and more features compared to it. So what are all the pros and cons with respect to the virtualization before you make the decision? Regarding the advantages, it is a better utilization of Exadata capacity, and you can able to get the maximum processing power out of Exadata machine. And it provides a greater cost savings. So whatever you need to spend on the additional hardware and the physical rack, you don't need to spend it. Rather, you can virtualize the existing setup, and then you can get the maximum out of it. And there are no additional cost for the virtual machine, so you don't need to pay any extra licenses or anything. And it provides a greater benefit for the consolidation of servers with the small workloads and consolidation of databases as well. For example, what we have done is we have just picked up so many small applications and put it into a bundle, and then we deploy it on the Exadata. That works perfectly good. So what are all the disadvantages? The first one is the neighbor noise and the performance impact. So as I said, some of the components which are not shared, so that potentially causes some of the neighbor noise, but even then the performance of the Exadata is still good. And we have additional stack that we need to maintain because we will have a VM layer, so we need to maintain the VM layer. And whenever we wanted to do any maintenance like a patching or upgrade, we still have to patch that layer as well. The very important operational issue what we face is a downtime coordination, because there are multiple applications that is hosted there. We have to coordinate with them in case if it is any issue with the physical machine or the hardware or anything. And the last point is the lack of documentation. So especially on the new KVM, that not much of a documentation available with Oracle support, and Oracle is developing those. So that's one of the disadvantage I see. The second component we are going to talk about is the storage server design. So many of us think like, okay, we have 3 storage servers and Exadata, every component is redundant. So the storage server also redundant. So I don't need to bother about whatever the disk group, whatever the redundancy I set for the ASM. No, that's not true actually, because the cell servers are not redundant. So every cell node that stores only one copy of data. For example, you have 3 storage servers that are listed in that are available in the Exadata machine. So it always maps with only one copy of data that is being stored, and only the redundancy exists only at the ASM level. It is not going to be at the cell server layer. But you can ask how we survive in case of a data loss. So how Oracle claims that it is the redundant device. For example, you have original data block that is exist on the second cell node. At the same time, due to the ASM redundancy, for example, if you set with the high redundancy, so the copy of data will be available at two different cell servers, which is at cell 01 and cell 03. So in case any one of the data that if we lost a cell server 2 or something, or any disk corruption, then automatically Oracle routes the traffic to the other cell server, and then from the database server, there are no impact. So even that same goes for the, even if you lost the entire cell server, that's still the same process works. So that's a quick background about the cell server configuration. So that redundancy is purely depends on the whatever you set at ASM level. So that's why you have to be very particular when you choose the ASM group redundancy, whether it's a normal or high. Of course, Oracle doesn't, Exadata doesn't support external, but still you have the option for the normal and high. So Oracle best prefers for the high configuration. However, based on your design, you have the option to choose for the normal as well. So there is one key parameter which we need to consider, which is a raw storage, whatever that's being displayed on the cell server. So you have to always consider the redundancy before you calculate the actual storage. For example, the server is provisioned with about 15 terabytes of data, and if you have a high redundancy, then whatever the usable size you get is only 5 terabyte or something. So you always have to take consideration of the redundancy whenever you do the raw storage calculation. So this redundancy plays a key role, especially whenever you are doing a cell node or a maintenance, because especially when you do a rolling reboot or something, so this comes into a picture, so that the traffic automatically flows into the other one, so that we are able to perform the patching or the rolling reboots on the other cell servers. The same goes for any hardware failures or software failures with respect to storage server. That's why Oracle claims it is completely redundant. So what are all the best practices that we need to consider? The first thing is we have to utilize the secret sauce of Exadata, that is relies upon its storage server only. The first thing is a smart scan, which scans only a particular blocks at the storage servers. And then cell offloading is a great feature of Exadata, where the heavy operation that's happening at the database servers, that gets offloaded to the storage server, so that your performance of the database server, including the CPU usage, is very less. And the storage indexes, like similar to a database indexes, we have the storage indexes that points the exact data rather than scanning the full data blocks, as well as we have the flash, which is a wonderful feature, which reduces the read IO as well as the write IO at the disk. But at the same time, we have to choose. There are two configurations that are available for the Exadata storage server, which is an extreme performance, which is purely a flash-based disk, and we have the high capacity, which is a SCSI-based disk. So we need to choose what is the configuration we need. So both has its own variations in terms of a capacity as well as the performance. So we have to choose the correct configuration. And very important is that the storage server works based on the NTP. So the time has to be matched across all the layers, be it from the database server or the ASM, so it has to be consistent. So it is our responsibility to maintain the NTP on all layers, which is very important. So possibly what are all the things which we can go up? So first thing is, don't perform any maintenance if any of the below criteria is met. For example, if the ASM deactivation outcome in the cell CLI, if it is not set to yes, do not perform any maintenance, because then you will have end up with the data failure. So always check for the ASM deactivation outcome status in the cell CLI command. The second one is do not service LED. There is on every machine you have a do not service LED. So in case if it is turned on, do not perform any maintenance on those machines. The next one is there is a blue or amber LED on the disk drives. So that means that the disk drive is having an issue that needs to be replaced, or it can be a predictive failure or a proactive failure. So we just need to check that out, and then until that becomes green, do not perform any maintenance on that server as well as the other machines. The second thing what we can go wrong is, as I said, the raw storage calculation that's converted into an actual usable size. So you can always refer this document ID 2176737.1, which will give you a pretty much good idea on how to calculate the exact size and how to provision or how to extend the Exadata systems in terms of capacity. And the third one important is do not mix data and record, because Oracle treats it very, very carefully. So whenever you choose the disk groups, please choose it very correct configuration and do not place your data files in record, not otherwise. So we talked about the design. Now we are just going to talk about the installation front. So there are a couple of things I just picked up. So first is the memory management and the second one is on the security. So what's new with the memory management, which is different? So the very key component, which is Exadata specific or the Linux kernel specific, which is a huge pages. So usually every in terms of a traditional machine, we have only about 4K memory chunks that is being allocated. So when it comes to a database, as well as, for example, if you're allocating about 48 gig of huge pages, then there are it reduces into so much of 4K blocks and then allocates to the database. So managing those particular pages itself a very huge task. So that's why Oracle or the Linux came up with a huge pages option. And in Exadata, we can choose the huge page size as 2 MB, and then multiple 4K blocks that converts it into a bigger chunk of 2 MB, so that the number of pages that Oracle or the OS has to maintain is very, very less. That gives a great performance. So how to control that number of huge pages or the memory that's allocated? That's in the nr underscore huge pages parameter that is inside the sysctl.conf. So the more number of the more number of pages, that leads into a performance issue. So it's always better to have the less number of pages. So whatever the database memory that you need to allocate go into the huge pages. So how do we control at the database? So at the database level also, we have to enable the use large pages parameter, so that the database effectively use the huge pages instead of the physical memory that's available on the server. So there are three parameters available with the init parameter. First one is a true and false and only. In case if you set with true, it always uses the huge pages. It doesn't go for the physical memory. In case if it is set false, even though you have some huge pages left, it is not going to use that. When you set with only, instance will start with in case if the huge pages is available, it will pick up, otherwise it will not. So that's a different parameter. So Oracle recommends only true. And what are all the possible advantages and the limitations? So the advantage of a huge pages is completely dynamic. So you can, as I said, you can just control the parameter with sysctl.conf, and then once you're done with that, just type sysctl-p, so it will pick up the new value. So it is always dynamic. So you can feel free to modify the settings based on your need. And the second thing is it is compatible with the SGA underscore target, and it is also a limitation where it's only compatible with the SGA. So whatever the memory that you allocate with the SGA, that only will use the huge pages. Whatever the settings or the memory you allocate for the PGA, that will not be taken into consideration. So always, whenever you calculate your huge pages, you will have to sum how much you are going to allocate the SGA for the all the databases. So accordingly, you can allocate the huge pages. And it provides a greater performance especially for the OLTP transactions, because the number of pages is very less, so the memory efficiency is very high. So what are all the limitations? The first thing I said is it's applicable only for the SGA, so the PGA is not into picture. So only the SGA memory that will be used on the huge pages. And in case if you are using automatic memory management using a memory underscore target parameter, then again your huge pages does not comes into a picture. So always you have to use SGA target and PG aggregate target. And the third limitation we have is whatever the huge pages you allocate, as I said, huge pages is used only for the SGA and none of the other components are going to use. And in case if you over allocate to the huge pages, then your physical memory, whatever that's less available, will be very, very less. So that will not be used for anything. So to avoid the memory starving, you always have to calculate what is the sum of the total SGA that you allocate, and then accordingly you allocate the huge pages. The second aspect we talk about in the installation is the security. The security is very, very important, especially for the critical systems like Exadata. And many of the times we often do a mistake like running with the default credentials. So during the installation, we will come up with the default credentials and then we start using it. And then after we start the migration and the installation, we forgot to change it. And there are some technical limitation that prevents that as well. So, what are all the things we just going to talk, and then we're just going to see how we can resolve that. First thing is, what are all the accounts that must be changed before you actually start your migrations or whatever it is. First one, at the computer or the VM layer, you have to change the root, Oracle, Grid, database admin, and DVM monitor. These are the accounts that definitely needs to be changed. And at the cell node, you have a root and cell admin user, cell monitor user, and cell dia. Those are the things that needs to be changed. At the ILAM, so ILAM is the interface that you can remotely manage your systems, even in case if your computer or VM doesn't respond. So ILAM is the one which helps in the maintenance or the remote support. So for that, you have a root, ILAM admin, and ILAM monitor. And regarding the power device unit, you have the admin user, and for the switches, you have NM2 user or the admin based on the switch configuration. So this is the master node, which is 129.168.1, which provides a detailed instruction on how to change the OS passwords for the cell node, database node, ILAM, KVM, IB, as well as all the devices of Exadata. So it is pretty much self-explanatory. So we can just follow the node blindly, and then we can just get rid of it. So what are all the do's and don'ts in terms of a password change? First thing is, please choose the complex passwords along with the character limitations. For example, we have for the PDU, we have the character limitation of 12 characters, and for the other things, the minimum is 8 and up to 32 characters it supports. So you always choose the complex passwords with the special characters and the character limitation uppercase and lowercase, and it should not be easily guessable. And it's always important you choose a different credentials for the various components. For example, when you select database server and storage server, use a different set of passwords. And the third important is stop the OEM and other remote logins, because by default Oracle comes up with the security credentials, security limitations. So in case if anybody attempt to log in with an incorrect password, so it will lock the user for about 10 minutes, and then it automatically unlocks it. So during your password change, if any of the OEM agent or any of the remote login programs try to log in, then the account will be locked and you will not be able to log in. So that's why we prefer to stop the OEM agent as well as the remote login programs. The SSH is not a problem. So whereas if it is login using the password, it is always stop those programs. And the components that are using the access points, that needs to be rediscovered. For example, in OEM, we have some components like an ILAM or the switches that works based on the access point. So those access point, you will not be able to change it dynamically. So always you will have to delete those particular targets and then rediscover in OEM. So there are some the credentials that are vault in the exacheck vault as well. So it's always better you execute the exacheck so that the credentials can be validated and it can be revaulted if it is needed. So what are all the don'ts with respect to the default credentials? First one is, do not use the shell specific special characters when you choose the password. For example, don't choose the dollar or a semicolon or a slash, which will impact the way the kernel interprets the password. And don't change the security settings without knowing the impact, because Oracle comes up with the default security settings. For example, what is the lockout time, what is the session idle time, and what should be the password characters. Do not change it unless you get the consent from Oracle. And very important is that don't expose the elevated credentials to many of the associates, as well as in case if you have a vault, so vault the password so that even if you forget, you will be able to retrieve it. And you verify the SSH key files and the permissions. For example, you have passwordless authentication between two different machines, and if the SSH key file which is exposed for the other with a higher permission, then your security is compromised. So always verify the key files as well as its permission. So next we move on with the configuration. So here we are just going to talk about migration and performance. So most of us have gone through migration, so I'm not going to talk about the special features or how to migrate and everything. So here we're just going to see how what are all the things we need to consider during the migration, especially for Exadata. The Exadata platform, it's not like a conventional traditional database machine where you can just do lift and shift. For example, whatever you run on a legacy machine, you just have the same init parameters, have the same configuration, move it to Exadata and then run it. It will still run, but that's not recommended. So you always have the flexibility to optimize the capacity, because in terms of a compute power or in terms of performance, Exadata is purely different. So you can always have the flexibility to reduce the capacity. For example, you have allocated 15 CPUs that is allocated on the legacy machine. When it comes to an Exadata, you don't need a 15 CPUs. Rather, you can run 10 CPUs or lesser. So calibrate the capacity requirements and then move it accordingly. Don't just follow the lift and shift approach. And the second thing is we need to be knowing about the contextual knowledge about the application, about the data that is going to be relied upon. That is very, very important, especially when you're using the hybrid columnar compression. So in order to completely reap the benefits of the Exadata features, you have to know about what is the data you're storing, what is the approach you're going to follow. So rather than keeping whatever the data you have on the legacy, moving it to Exadata and then keeping it running, you are try to understand the in-depth of those particular systems and then choose the benefits so that you will be able to get the maximum performance out of it. So there are some unit parameters both at ASM as well as at the database that enables to use the features. At any cost, do not change those parameters or don't try to modify, so that then your performance will severely be impacted. First thing is cell dot smart scan capable. This parameter allows you to use the smart scan feature. Same way, cell upload processing, it always has to be true, so that your database specific operation that can be uploaded to the cell server. And we talked about the large pages, so that will enable the huge pages. And we also have a parallel min and max target, so that also have a severe impact on the performance. So we'll talk about in the performance slide. The next one is the cell flash cache. So this will enable the flash option in the storage server. So you always have to choose the keep option in the tables which are mostly frequently used. So when you set it to keep the particular tables, like we pin in the shared server, the particular table will be kept in the memory of the storage server also, so that the IO operation that goes into the disk will be very, very less. And you choose the appropriate hybrid columnar compression option. We have low archive as well as medium, so you can choose whatever the option you want to choose. And you always have prefer the direct RDMA read and a full table scan, so that the operation, rather than performing at the database, will be cascaded to the storage server. When it comes to performance, as I said, we have to make use of the maximum benefits that we get out of Exadata. So there are no rule of thumb, but because it varies based on application to application. However, I just give some options that you can just use it. So first one is a simple repeated operations like a regular OLTP transaction that is going on. Always try to use the flash. As I said, you can just use the cell flash cache as well as other specific features of Exadata, so that your transaction always uses the flash and it will be very, very fast. And for a heavy operations like a data warehouse or you have a huge table that needs to be scanned, try to offload it to cell so that your database CPU and the memory is less consumed, and your performance also is much faster when the cell offload feature is being used. So you can, in case if it still picks up the index, you can try with a hint of full so that the operations can be uploaded to the cell and then it will be efficient. The next one on the database indexes. So when it comes to database indexes, use them only if needed, whereas try to use the maximum on the storage indexes so that your need for maintenance at the database is very less. At the same time, storage indexes are dynamic. It is not static, but it can rebuild as and when based on your queries. And you have the flexibility to choose the IO resource manager as well as database resource manager. You can use them, but we have a caveat there, which is a CPU quantum. So always check for the wait event, and then you can use the resource manager. The last one is the parallelism. As I said, Exadata is a very huge in terms of the CPU. So by default, Oracle will pick up the maximum CPUs that is allocated, and then it will try to use the parallelism settings. For example, parallel min server, parallel max server, and parallelism target. So, but you don't allocate the entire parallelism to one particular database, so that whenever the query runs with multiple parallelism, it will eat up the space, and then it will eat up the memory, and it will cause the machines to hang. So always set up the parallel min server, max servers as well as target with the correct appropriate parallelism that is needed for your application, so that even when you run with multiple parallelism, your system performance is still being maintained. So that also goes for the degree of parallelism set at the object level. Choose the values appropriately. The fourth parameter we are going to consider is the health check. So here we are just going to talk about how to monitor and what is the features of AHF. So when it comes to an Exadata monitoring, we have various components that we need to monitor. So there are some the Oracle Enterprise Managers that is by default covers with all the components of Exadata. It has special plugins, and it is especially designed for monitoring the Exadata, and it's the best tool for monitoring. And apart from that, you have the other options as well. For example, to monitor the Exadata compute instance, we can better manage using the DBM CLI, as well as we have an ILAM, either both provided with the GUI and CLI option. And we also have an IPMI too. And for a proactive monitoring, we can use the AHF. So all these parameters I would highly recommend to be enabled, and then to be monitoring it as well more frequently. And when it comes to a storage server, the only change is that instead of DBM CLI, it will be cell CLI that you need to manage. So where you can just see all the alerts that are outstanding, what are all the issues that is ongoing. So everything, what is the disk status, all those things that can be understood by the cell CLI. Same, we have the ILAM for the storage servers as well. So we can just check the status of the machine in case of any memory failures or whatever it is. So when it comes to an RDMA networks, we have the Oracle Enterprise Manager, and then we can monitor them using the ILAM CLI also, because that captures some of the data. And we can always check using the AHF framework. The next one on the Exadata VM, we have Exadata Enterprise Manager, as well as we have the AHF, as well as OS report, something like the SOS report, as well as we have a crash report that is recorded on the U01 flash files directory. And when it comes to database, pretty much we know, like, we can use the Enterprise Manager or database performance reports, be it AWR, ADDM, or ASH. So those are some key parameters that we always have to watch out. So if you look at it, we have two outstanding things. One is an Oracle Enterprise Manager that is a better one to cover all the components, as well as we have AHF, which is also monitoring or it gives a proactive reports. So what is, we'll talk about AHF in the next slide. So what are the best practices that we need to consider in the monitoring? So whenever you choose a monitoring, always choose the latest version of Enterprise Manager, as well as the latest plugin and the patch release, so that whatever the bugs we identify notify across the versions that has been fixed so that you avoid unnecessary alerts that you get it. The second thing is you all with respect to plugins, you always choose the correct plugins as well both at repository as well as at the target agent so that it works coordinates better. And you always configure the alert and the incident routes and then review them periodically, ensure that you are getting all the alerts. And at the OS level, for example, cell CLI or a DBM CLI, you have the SNMP option. So you will have to enable the SNMP option so that the alerts will be sent to OEM or send it via an email. So ensure you configure the SNMP configurations at all the layers, be it at cell server, cell CLI as well as DBM CLI. AHF also provides a notification option, so you can enable the AHF notification or a TFA. TFA is nothing but trace file analyzer notification, so that instead of waiting for the tool to detect and route, so AHF or a TFA will send a proactive notification that will help you to troubleshoot the issue much faster. So you always receive a weekly summary alerts that you will be getting from the compute instance and the cell nodes. So review them periodically and then ensure that there are no alerts that are reported. And the ASR, which is an automatic service request option. So Oracle will monitor your devices and that's like a platinum gateway you get. So in case if you don't have any restrictions, use the ASR so that there are additional pair of eyes that are monitoring your systems. And review the reports always and ensure that the alerts are being maintained as well as it's running with the error-free system. So what is an AHF? So AHF is Autonomous Health Framework. So previously it was we had multiple different kind of framework. We had like only Exacheck or OS Watcher, so which are maintained locally. So Oracle integrates everything into one bundle. That's an AHF. So you can refer the master note for the latest version as well as you can download the latest version. So the AHF is updated every month, and you also have the option for the automatic upgrade as well. So how to install AHF? So when you just need to run AHF underscore setup and then you just give the location where you want to install. So it just install all by itself. So you don't need to manually configure anything. It is a very easy installation. So when you install AHF, all the other below components that also comes up with it, Exacheck or the OraCheck and the OS Watcher and the Exa Watcher, and you also have a trace file analyzer, OraTap, ADR. So all the components that you need for monitoring the system that comes up with AHF. So what are the features of AHF? So first thing is it is very proactive. So rather than being a reactive after the issue happens, AHF provides all the recommendation that you needed to run your mid systems very high efficient. So it is a very highly proactive tool that you can use. And in case of any failures, AHF will automatically collect all the logs and it also bundles it together and helps both Oracle support as well as ours for troubleshooting. So that's the best feature of AHF, and that's why Oracle always asks for you to provide the data from the Exacheck reports or whatever it is. And it is a single diagnostic and integrated interfaces for all your troubleshooting process. And it's a pretty much easy installation, so you don't need to worry much. The next feature is the automatic upgrade. So that's a special feature what we have for the AHF. So in case if you want to set up with an automatic upgrade, so you can do both offline as well as online. So there are some options that are available. So when you set with the set upgrade all, and then either you can give a stage location or from where you can just download and stage. So automatically AHF upgrades. So you don't need to update it manually. So what we have done on our step is we have just pushed the new software as and when available to all the servers, and AHF will automatically update it once in every 30 days or something. And we also have the automatic notification option, which we'll talk in the next slide. So that features will send an email alert or a SNMP trap so that the alerts can be captured. So you don't need to manually log in and check each and every time. The another important features that AHF provides is the automated differential report. So what this particular automated differential report does is it just compares the Exadata status of the previous day and today, and in case if it finds any difference, then it automatically sends an email, and it also gives you the differential data. So what was my Exadata score yesterday, as well as what is my Exadata score today. So this is a very good feature where you can see if something goes wrong between the 2 days, as well as what are all the things that are improved between these 2 days. So how to enable the age of notification? So you can just set via TFACTL set age of notification. So when you set with age of notification, all the underlying components are enabled with that particular email ID. For example, when you set with age of notification, it also applicable for the traceable analyzer. It also applicable for Exadata and all the other components that it will pick up. And you can also set the passwords at the TFACTL using TFACTL set password. So whenever the Excel check runs, you don't need to manually enter the password. Rather, it is like a vault that you can vault your credentials. You can, instead of setting an age of notification, for example, you want to set a different notification setting for a different type of databases and everything, you still be able to do it using the individual notification. So you can check the OracleCheck notification or Excel check notification or a TFA. You can individually set the notification as well. And as I said, Excel check also can be run at the background, so you don't need to run it every time manually. So you can just schedule it using the Excel check -set, and then you can just check set the auto run schedule and the notification. So every time it runs, and then it gives you the data. The next option that Oracle provides is previously up until now it was using the HTML. Now we have both HTML and REST based option that you can use. So what are the best practices of AHF? Always use the latest version and use the differential reports, and you try to include all the components whenever you run the AHF. And what are the credentials, and run the Excel check with the cluster node in case if you have both the clusters. And the last one is the Excel check -ID. So in case if you want to specify any specific Excel check finding, you can use Excel check -ID. The last one on the list is the maintenance. So we have two types of maintenance we do. First is the hardware maintenance. So the high availability of the Exadata system that relies on its hardware stack. So always you have to maintain the system. So there are two types of components. We have hot swappable and cold swappable. So storage devices are the fan or power modules. Those are like hot swappable, so you don't need any downtime. When it comes to cold, it has memory modules, PCA hardware, as well as the physical hardware. Those are like hardware maintenance. So what are all the things? So this is the typical procedure. So you get an alert, so you collect all the data, upload to Oracle support. Oracle will deliver the part, and the field engineer will come and replace the component. And in case if it is ASR, it automatically performs by your end. So what are all the do's and don'ts when it comes to hardware maintenance? So always review the alert and locate the exact failure, and you specify the exact component, and refer the database maintenance manual that is available at the Oracle Docs. So that will give you the detailed procedure what you need to do. And you also perform any action, don't perform any action without the consent of Oracle, and do not remove any components without any of the specific things that are being maintained. And don't perform any maintenance especially when you have an amber or a blue LED. So ensure it becomes green. The last one on the list is lifecycle maintenance. So we have to maintain the system so that we can always keep up to date. There are two things we do most frequently. First is the system upgrade as well as the system patches. At the right hand side, you can see what is the release schedule. For example, Exadata storage data releases every month, whereas the feature releases are released 6 to 18 months. So always recommends to run it. When it comes to database, we have the long-term releases, innovation releases, as well as the PSU. So ensure that you run the system with up-to-date settings. So when it comes to different for the Exadata, you have to patch the components like a storage server, database server, as well as RDMA, and we also have to manage the GA as well as databases and PDUs. So there are two types of patching we can do. Some components you can do via rolling, and something of a non-rolling as well. You can just choose based on your configuration, and you have to specify your lifecycle management strategy and identify the target releases. Run the Excel check so that you can able to get the exact error, and then before your upgrade process. And download the softwares and run the prerequisite and check for the conflict patches of the software. And then in case if you want to do a switchover of the workload, you can just do it, and then you can patch the systems and verify the patches. And important is that run the Excel check again, ensure that there are no errors reported after the process. Some of the best practices, you always follow the sequence of patching, so don't just go randomly. So as well as review the SR detail and then follow the specific nodes, and ensure that we have sufficient free spaces available at the servers, and unmount the NFS or ACFS or the other utilities. Ensure that the applications are moved to the other nodes so that you can perform the maintenance, and always maintain the uniform versions across all the different environments. So don't ignore any of the errors or warning, and very important is that don't interrupt the patch process because it is custom built. And in case of any rollback that's needed, follow the proper downgrade procedure so that it gets into it. So here is my channel. So whatever we just touched upon various areas. So if you follow my channel, you can able to get more details about each and everything. So you can follow me on my LinkedIn as well, and then you can post me for any questions or anything. Thank you.
Thank you so much, Manny. I see one question from Dan Grant. Yes, the recordings will be available from all sessions. Basically, when you register to your session, when you register to any sessions to watch in the system, in your top right corner of the page of the event, you will have your attendee tab. In attendee tab, you're going to have your personal agenda with all sessions that you register to. And there, if you click in the session you register, you're going to see the replay link to the sessions. We just uploaded the first 9 days of the event videos, and we are uploading the next 3 days, today and tomorrow, and then Monday finish with all the other recordings. And all the recordings will be available until December 30 through the platform to watch as many times as you wish. Anybody has any other question? Looks like not many, but if any questions, the people will use your contact information that you show in your presentation, and they can contact you at any time, even when watching the replays, if they have any questions for Manny. And say that, Manny, thank you so much for connecting for so far away from Norway, and by taking your time to share your knowledge with not only the Asia Pac community, but the global community that participates in this conference. Thank you so much, Manny.
Thank you so much, Francis, for all your great support, and I especially thanks to APAC as well as all the sponsors and Oracle Groundbreakers.
Fantastic. Thank you so much, everyone. Have a good morning, afternoon, or evening, wherever you are, and please take care and be safe. Bye-bye.
Have a nice day. Thank you. Thanks a lot.
Cloud DB, shaping your new normal.